All right, good morning guys, and welcome to the last video, I hope, of the year. I miss all of you. I wish that we were here together to go over the review, but we'll do what we can. So, all right, so we're gonna start off with probability given a two-way table. So before I even start, in a two-way table, almost always we're dividing by the total, which is right here. I call it the total, right? The only time that we're not dividing by this number, right, this cell right here, is if we have what's called conditional probability. All right, so with conditional probability, you can recognize it because they use something like the word, the phrase given that, or they say out of the so-and-sos, right? And this wouldn't be like the entire student body or the entire sample or whatever. It was like out of the boys, out of the girls. Or if a student is blank, like female, or if a student is in the band or whatever. So these are conditional probabilities, and in this case only do we divide by either a column or row total. So what I mean is conditional probability, you would divide by one of these or one of these. Okay, otherwise, unless you see something like this, you're gonna divide by that cell 88. Okay, so now that we've talked about that a little bit, let's go ahead and familiarize ourselves with the question. So it says a random sample of 88, there's our 88, 11th and 12th graders was selected. The two-way table summarizes the gender of the students and their response to the question, do you have allergies? Suppose we chose a student at random from this group. All right, so here's our allergies. They either have allergies, yes or no. And so we can see 34 students total had allergies and 54 did not. And then they were also asked if they were male or female. And so we see that 43 students, so female versus male, right? 43 students were female and 45 were male. All right. What does this number represent? The 19. So this is called joint probability. These are people who are female and said yes. What does this 15 represent? These are people who are male and said yes, they have allergies. This 24, what does that represent? This 24 were females that said no, they do not have allergies. And this 30 is males that said no, they do not have allergies. Again, that's joint probability. So this is male and no allergies. This is female and no allergies. This is male and allergies, and this is female and allergies. Okay, so it says, what is the probability that any student, the student, so out of everybody, out of 88, has allergies? So out of 88, the probability that they have allergies, let's see, allergies, yes, would be 34. The notation for that, and I know that they're not asking for it here, but the notation is the probability of allergies, A. Okay. What is the probability that the student is female or has allergies? Okay. So we have ands. I already talked about ands. Ands are these four clouds right here that I bubbled, right? These are, they're doing both at the same time. And then the notation for that is like the probability that a person is female and has allergies. So that means and. The notation for or is the probability that that should be an F, right? Is female, let me fix that, is female or has allergies. Now again, they're not asking you to use the notation, but you need to be familiar with it because all of us will be taking state tests at some point, and so you're going to need to know these notations. Oh, by the way, so this one, I didn't mark it, but do we agree that 34 out of 88 is right here, B? Okay, so I just want you to be comfortable with that notation. So female or allergies means they could be female, or have allergies, or they could be both. All right, so there's two ways to do this problem. I'm gonna use the table. I think this time I'll highlight with blue. So let me get my blue highlighter. Okay, so they could be female, right? So I could take all the females, which is 43, plus they could have allergies. So I'm gonna take all the people with allergies, which is 34. Or they could be both. Well, now I've already added in the both right here. So what has happened is when I added these, right, this 19 and this 15, I got 34, and I added 19 and 24 and got 43. So what I've done is I've double counted these 19 people. And so I have to remove those 19 people from my counting because I can't count the same people twice. So I counted these people twice. So I'm going to remove them. And this is all out of my total, 88. So this is one way to do it. And this is actually called the general addition rule. So the general addition rule is the probability of A plus the probability of B minus their intersection, or minus their overlap. So this is one way to do it. And when you add 43 and 34, you get 77. And then if you subtract 19, you will get 58, right? So 58 out of 88. Now this is the method that most students will use, but I also find students like this method. So if they're female or allergies, so that would mean I would just take the people who have allergies, which are these people, and then the females, well, I've already counted them, so these people. So I would say, okay, that's 19 plus 24 plus 15 out of 88. And this will give me the same answer. 19 plus 15 plus 24 is 58. So you can do either method that you prefer. I just want to remind you that on this method, right, you're counting this 19 people in this group and in this group, and you can't count the same people twice, and that's why we subtracted them out. Okay, if the student has allergies, so this sounds like what I was saying here. If a student, right, so this time it says if a student has allergies, so this is called conditional probability. So now I know I am not going to divide by 88, so I can get rid of B. Conditional probability will never divide by the total. It will always divide by either these two, one of these two, or one of these two, okay? Or so if the student has allergies, so they're asking you to restrict or condition yourself to one category. The one category is right here, the students who said yes, that they have allergies. So out of these people only. So this is the probability that they are female, given that they have allergies. So it says, given that the student has allergies, what's the probability that they're female? So this is given that. All right, so you don't have to know that notation, but we're going to take out of the people who had allergies, so out of 34, those that were also female, which is 19. And so 19 out of 34 would be right here, D. Okay, now it says, which of the following is true about the events student is female and student has allergies? And they're going to start asking us about them being mutually exclusive, independent, neither, or both. So before we move on, I'm going to talk about what mutually exclusive is. I'm going to take out a separate sheet of paper here so we can take a look. So we've got some rules about mutually exclusive. So I guess I'll flip this over so I can use the top. So mutually exclusive, I'm just going to call it ME, or another word for that is disjoint. They can use either word. They're the same thing, so AKA, right? Also known as disjoint. Mutually exclusive or disjoint means the events cannot happen at the same time. Oops, the events cannot happen at the same time. So let me give you an example of that. In a Venn diagram, there's no overlap, right? They don't touch. Now let me give you a real world example of that. Being a fish and being a mammal. Right? A fish is not a mammal. A mammal can't be a fish. I know you want to, maybe you're going to say a whale. Whales are not fishes. Whales are mammals. Right? So that's a real world example. Another real world example. Rolling an even number, rolling an odd number. Numbers are either even or odd. You cannot do both at the same time. So this is an example of a disjoint event. So let's just go back and look at our table and talk about, in the table, was anybody both female and had allergies? And yes, there were. There were females with allergies. There were 19 people that were doing that. And so they are not mutually exclusive. So this would be mutually exclusive. And in this case, these are not mutually exclusive, since you can be both. Okay? So they're not mutually exclusive. All right, and then independent, there's a different set of rules for independence. They're not the same thing. They mean two totally different things. Mutually exclusive means that one event can't happen at the same time as the other. Independent means that the outcomes don't affect each other. So actually, if this happens, they're automatically not independent. So the rule for independent, in words, right, one event does not affect the other. Now, in general, in like real life, we don't think that being female or having allergies, that one is more prevalent than the other. But I don't know, actually. I mean, maybe more females do have allergies. Maybe more males have allergies. I mean, there are certain disorders, like blood clotting disorders, that only males get. There are certain disorders like COVID. More males are affected by COVID than females, right? More males tend to get it than females. And so in this case, it's perhaps one outcome is affecting the other. So we have to check. You must check. So there's a check for this mathematically, and it's not that bad, right? The general rule is the probability of A and B, remember that means and, is equal to the probability of A times the probability of B. Well, I don't want to use A's and B's because we're talking about allergies in females. So instead, I'm going to use A's and F's. So I'm just going to change this to an F to represent a female. All right, so the probability of having allergies and being female. Well, let's find that in the chart. So in the chart, the probability of doing both at the same time is 19 out of 88. And that should equal, so if this happens, if yes, then they are independent. If it doesn't happen, then they're not independent, or we call them dependent, right? The opposite of independent would be dependent. All right, so 19 out of 88 is the probability that you have allergies and being female. Now, is that equal to the probability that you have allergies? So the probability of having allergies is all of these people, 34 out of 88, times the probability that you're female, and that would be right here, 43 out of 88. Now you can change these into decimals. Please make sure you know how to divide fractions. Whoops, oh, my battery's almost dead. So let me plug this guy in really quickly before it dies. Find the charger. Oh, here it is. No, that's not it. Oh, I don't know where it is. Well, I'm going to go ahead and try it really quickly before I waste too much time. Okay, so 19 out of 88 is 0.21, I would say 6, because it's going to round. Is that equal to 34 out of 88? So 34 divided by 88 is 0.386. And then 43 divided by 88 is 0.489. So I'll multiply those last two and see if it equals 0.216. If they're equal, I'll say they're independent. If they're not equal, I'll say they're not independent. So 0.386 times 0.489 is 0.189. And so 0.189 and 0.216 are not equal, so they are not independent. So what we have decided now is that we have events that are not mutually exclusive and they are not independent. And so we would say for this one, the events are not mutually exclusive, but they are independent? No. The events are mutually exclusive. No, they're not. The events are not mutually exclusive, nor are they independent. There we go. All right, guys, I'm going to look for my charger really quick because I'm going to need my calculator for the next question. So give me 1 second. I know it's in one of these drawers. I just have to locate it. There it is. Okay. So cool that it's rechargeable, but sad that it's dying right now. Okay. Next one, I'm going to just tilt this out just a bit so you guys can see the edge of my paper a little better. There we go. Okay. More probability. So I actually decided to give 4 probability practice questions because you guys struggled with probability in the beginning of the year. So I wanted to make sure that you had enough examples that you would feel comfortable with probability. All right. So let's familiarize ourselves with the table. So it says that we have Instagram or not Instagram, Pinterest or not Pinterest. There are people who do both, right? That use both Pinterest and Instagram. So I'm already going to tell you that these are not mutually exclusive events because all of the cells are filled. You can use both at the same time. If these cells were empty or zeros, then they may be mutually exclusive. Okay. So this question says, what is the probability that a person uses Instagram given that they do not use Pinterest? Okay, so given that is going back to conditional probability. So remember that normally in the two-way table, almost always we divide by 100. And the only time that we won't do that is using conditional probability. So in conditional probability, we'll either divide by these, 71 or 29, or we'll divide by these, 68 or 32. So it says, given that they do not use Pinterest. So we're looking only at those who do not use Pinterest. So this is my denominator, do not use Pinterest. So I'm going to look at only this column. So out of these people, so out of 32, what is the probability that they do use Instagram? So we're looking for uses Instagram in this column only. And whenever you're using given that or conditional probability, you should only be pulling numbers from the column that follows the words given that. All right, so that would be 26 out of 32. And the notation for that would be the probability that they use Instagram given that they do not use Pinterest. So I'll say Pinterest complement. All right, 26 out of 32, and I think they want it as a decimal. If they want it as a decimal, it should tell you which decimal place to round to. 26 divided by 32 is 0.8125. So 0.8125. Now, I don't know. I can't see the drop-down menu, so it could have been it was just 26 out of 32. Or they could ask you to simplify, meaning like that both of these are divisible by 2. So they could ask you to write it in simplest fraction form. If you divide both the top and bottom by 2, you'll get 13 out of 16. So it could be 13 out of 16. They could have 26 out of 32 or 0.8125, or they could have rounded that 0.8125. The probability the person uses Pinterest given that they do not use Instagram. So again, they use Pinterest given that another conditional probability they do not use Instagram. So whatever follows the phrase given that, which is not using Instagram, that will be my denominator. So I'm going to look in the row or column where they do not use Instagram. So do not use Instagram is this row. I will only take numbers from this row then. So the probability that they use Pinterest, given that they do not use Instagram. So out of those who don't use Instagram, that's 29. The probability that they do use Pinterest, which is 23. Now this one does not reduce, both of those are prime numbers. As a decimal, 23 divided by 29 is 0.7931. And then it says, are the events use Pinterest and use Instagram independent? Independent means that the probability of Instagram and Pinterest is equal to the probability of Instagram times the probability of Pinterest. Mutually exclusive, we've already said that they're not mutually exclusive because you can do both at the same time. All of these cells are filled. And so neither or both. So we know it's not both, and we know that they're not mutually exclusive. So it's either neither or independent only. So let's take a look. We're going to check for independence. So our check for independence, the probability of Instagram and Pinterest. So that's out of everyone. So out of 100, they're doing both. They use both Pinterest and Instagram, which is right here, this 45. So 45 out of 100, which is 0.45, is equal to the probability that they use Instagram. So the probability that they use Instagram, there's 71 Instagram users out of 100 people, which is 0.71, times the probability they use Pinterest. So out of the Pinterest, or all of the Pinterest users are 68 out of everybody, which is 0.68. And now I'm going to check in my calculator if 0.71 times 0.68 is equal to 0.45. So what I have is that 0.45 is equal to 0.4828. They're close, but they're not equal, so they are not independent. Oh, I see right here A and B were down here. Oh, silly me, right? There they are. Duh. So it would have been this guy and then this guy, 0.81. So they're neither. They're not independent and they're not mutually exclusive. So C. All right, now we're going to practice that same skill, but this time we're going to move to a Venn diagram rather than a two-way table. So in the Venn diagram, let's discuss the Venn diagrams first. We have two circles. So we've got this circle, all of these people, right? These are all people in drama. And then we have this circle. These are all people who take music. And then we have this overlapping area right here, which I'm actually going to see if I can highlight it with two colors and see if we can turn it green. Oh, yay. It's kind of greenish, right? So that green area, these people are in both. They're in drama and in music. These people over here, they're only in drama. And these people over here, they're only in music. And then finally, these people out here, they don't take either drama or music. Okay, in the Venn diagram below, there are 9 students in only drama, 7 students in only music, 15 students in both programs, and 12 students in neither. So it says, what does A and B represent? So that's their overlap or their intersection. It's their and, right, where they're doing both. And so that would be the students in drama and music. All right. Now it asks, what is the probability of A and B? You may use a fraction or decimal rounded to the nearest tenth. So the probability of A and B would be out of everyone, they're doing both. music, and drama. So we know that it's 15 out of, now we have to figure out how many people are represented. So we had 12 plus 7 plus 15 plus 9. That's your entire sample space. And so you're going to add up the 12 plus 7 plus 15 plus 9. And so 12 plus 7 plus 15, okay, so 19 plus 15 plus 9 is 43. So this would be 15 out of 43. Now, if you want to use a fraction, you may. If they want it as a decimal, you're going to take that 15, you're going to divide it by 43, and you get 3488, and it says to the nearest hundredth. So I have 0.3488. When I round to the nearest hundredth, this is the tenths, this is the hundredths. I look at this digit, this would round this number up, and so this would be 0.35. Or you could have left it as a fraction. All right, next we have, what is the probability of A or B? And so in words, this means or. So we're gonna look at that probability. It's actually easy in a Venn diagram, right? The probability of A or B. So you could just be in drama, you could just be in music, or you could be in both. And so you're going to add those together. The probability of A or B is 9 plus 15 plus 7 out of everybody, which we said was 43. So that would be 24 plus 7, 31. 24 plus 7. I never trust my math skills on the weekend. So 31 out of 43. Again, I think you can leave it as a fraction. If you do divide it, 31 divided by 43 is 0.7209, so it would round to 0.72. So 0.72. All right, the probability of B in a Venn diagram, B is, I'm guessing, right? They didn't say which one was B, but we're gonna let this one, since we generally call like this side A and this side B, we'll call B this side the music. And hopefully that was the way they did it in the, oh yeah, it says student is in music. Probability of B, student is in music. Awesome. Okay, so the probability of B is everyone who's in music. So that means these people, but these people as well, because these people are also in music. So it would be all of these people, right? The entire circle B, which is 15 plus 7 out of everybody. Again, no conditional probability. So we're always going to divide by the total unless it's conditional. So that's 22 out of 43. You may leave it as 22 out of 43, or 22 divided by 43 is 0.511. So that would be 0.51. All right, and then B complement. So B complement means they're not in music. So the people that are not in music is everyone outside of this circle, which would be this 9 and this 12. So it'd be 9 plus 12 out of everybody, which is 43. That's 21 out of 43. And 21 divided by 43 is 0.488. That would be 0.49. Now, you notice that these two, you either are in music, or you're not in music. So these two will have to add to 100%, and they do. So another way to have done this problem would be, okay, well, I know I have 0.51 that are in band, so I could do 1 minus 0.51, and that would give me 0.49. All right, and that's the complement rule. Last one on probability. And then I think I'm going to pause it here so that the video doesn't get too terribly long. The Venn diagram displays the information about boating and fishing in local lakes and whether those are allowed. The set of lakes that allow fishing is represented by F, and the set that allow boating is represented by B. And it says, find and express the following probabilities as a reduced fraction. So these ones we're going to leave as a fraction, but we're going to reduce the fraction if it reduces. So first, let's determine how many people boat. All of these people boat. So there's 11 boaters. or all of these lakes allow boating. So there's 11 lakes that allow boating. All of these are lakes that are where fishing is allowed. So there's 17 lakes that allow fishing. And then this overlap right here, these 7 lakes allow both boating and fishing. And then there are 3 lakes in the area that don't allow either one. All right, so this is conditional probability. This is given that, or conditional probability. So this says, what is the probability that they allow boating given that they allow fishing? All right, so the probability that they allow boating given that they allow fishing. So that means that we can only divide by the fishing. So out of all the fishing, which is these guys, what is the probability that they also allow boating? The rule for, or the formula for this, the probability of A given B is equal to their overlap, right, their intersection out of this one, B. So in our case, it would be the probability of fishing and boating out of the probability of fishing. So out of the fishing lakes, which is out of 10 plus 7, what is the probability that they allow fishing and boating? Fishing and boating would be 7 out of 17. Done. All right, the probability that they allow fishing or boating. So this is or. Now in a Venn diagram, we already talked about how easy that is. You just add up these 3, fishing, boating, or both. And so that's going to be 10 plus 7, whoops, not 17, 7 plus 4 out of, now this time, the only time we don't divide by the total is in conditional probability. So it's not out of 17, it's out of all the lakes, and there are 3 more lakes that we did not, or sorry, there are 10, 17 plus 4 plus 3, so 17 plus 7, which is 24. So 10 plus 7 plus 4 plus 3. And so this is 17 plus 4 is 21 out of 17 plus 7 is 24. Now, if you notice, these both have a common factor. 3 goes into both of these, and so they do want it as a reduced fraction. So we need to divide this. 3 goes into 21 7 times, and 3 goes into 24 8 times. So that would be 7 out of 8. All right, the probability of fishing. Again, the only time that we don't divide by all 24 lakes is example A, when we have conditional probability. This is not conditional, this is not conditional, this is not conditional. So this, all 3 of these will have a denominator of 24. So the probability of fishing is out of 24.